We have a go for engine start. 6, 5. We have main engine start. 2, 1, 0. Engines are now at 100% of rated power.
NASA orders Endeavour's 3 main engines replaced after problems are detected inside 2 of its rocket motors. The decision is made just 2 days after the flight readiness firing of America's newest space shuttle. But with brand new engines now installed on the orbiter, NASA says Endeavour is ready to fly.
We've done an awful lot of work to it here at Kennedy as well, and we feel like the level of work that's gone into it has been tremendous.
The Atlantis astronauts let the sun shine in as they focus their instruments on the star of our solar system. New revelations about the sun's impact on Earth may also be on the horizon, thanks to the crew of STS-45.
Rick, we've just got everybody oohing and on. We don't know when we're going to get Mikey to go to sleep. He's never seen this good of an aurora before.
We're going to make a real auroral believer out of him.
And have you ever wanted to take a peek inside the vehicle assembly building? Well, stay tuned, because we're going to take you behind the scenes at the Kennedy Space Center, and we'll show you how the shuttle launch team stacks up.
Specialist JF.
And liftoff of Atlantis and the Galileo spacecraft.
They have preconceived notions. I wanted a tip-off is not great.
The only thing absent was family and friends, but
nose gear touchdown.
For April 1992, this is Shuttle Vision, Volume 1, Number 5.
Hello, I'm Anita Vogel.
And I'm Tom Marshall. Welcome to the Kennedy Space Center in Florida, where the Space Shuttle Endeavour is poised for liftoff. Engineers are examining the orbiter's main engine compartment this month, having successfully completed the flight readiness firing of the main engines. That was on April the 6th. In a moment, we'll show you the FRF and tell you why this test is so important to NASA engineers.
We'll also take you to Launch Complex 39B for an update on the final touches being put on Endeavour. Shuttle Vision's Richard Horman is standing by at the launch pad with a report. And of course, the other big story to tell you about this month, the confirmation of Daniel Golden. The new NASA administrator was here at KSC for the landing of STS-45 on April 2nd. And in a little while, we'll tell you what he had to say about the future of America's space program.
And talking about STS-45, complete mission coverage of the flight of Atlas 1 is coming up. But first off this month, our cover story, the countdown to Endeavour.
Endeavour features the improved auxiliary power units. They also will be tested in the vehicle.
The external tank was topped off with the usual 500,000 gallons of cryogenic propellants. The crew access arm was moved away from the shuttle, and a NASA commentator in launch control counted down the minutes. It seemed to have all the makings of a regular space shuttle launch, but 22 seconds after main engine ignition, the orbiter's general-purpose computers would detect a failure, and one by one, the 3 main engines would be shut down. In short, this would-be launch was headed for an imminent abort. But that's what NASA was hoping for. After all, there are a few things missing from this countdown, namely the astronauts. There's no one sitting in the cockpit of the shuttle, and the cargo Endeavour will eventually carry into space has not yet been loaded into the payload bay. And even if engineers had not tainted the countdown with a bogus malfunction, the SRBs wouldn't ignite anyway. The explosive devices used to light the boosters have not been installed. But this countdown will not be in vain. Quite to the contrary, NASA is carrying out a very important mission on the ground. It's called a Flight Readiness Firing, or FRF. A required test for all new orbiters, the FRF checks out critical elements of the integrated shuttle system. Because Endeavour has never flown before, NASA wants to make sure the orbiter's main propulsion system and internal components are operating properly. And in this case, the FRF is giving engineers a chance to test the main engines that have been installed on Endeavour. They, too, have never flown before.
T-minus 1 minute and counting. T-minus 45 seconds and counting. At the T-minus 31 second mark, we will get a go for auto sequence start. T-minus 31 seconds.
Go for auto sequence start.
Endeavor's 4 redundant computers have primary control of critical vehicle functions for the remainder of the count. T-minus 20 seconds. Sound suppression water will be released on the launch platform. T-minus 12, 11, 10, 9. We have a go for engine start. 6, 5. We have main engine start. 2, 1, 0. Engines are now at 100% of rated power. 5, plus 6, plus 7, plus 10, plus 11, plus 14, and we have an abort.
Pass is going 101, LVD 1 and BFS 0.
And everything occurred according to plan today. Safing operations are underway.
Zones 1, 2, and 3 are now showing post-shutdown standby, and we are go for orbiter APU shutdown. Copy. No MPS fire detector tripped at this time.
And the abort is planned as normal for a flight readiness firing to shut down the main engines.
Cutoff of the main engines was initiated by what NASA calls an induced redundant set launch sequencer. The RS-LS was able to bring the successful firing to a halt. Preliminary data looked good, and although it would take several days to assess all the information, the stage seemed to be set for a real launch in early May.
It gives you a lot of confidence in the flight systems, and based on the real-time data that looked to perform all within spec. We still have data review to perform, but the quick look says it went just fine.
We're going to have a meeting a little later this afternoon where all the engineers will review with us the post-test data, but every indication we have is things went just as we would have liked them to. And so we think we're on track for launching this vehicle early next month.
But only 2 days after the FRF, NASA managers announced that problems had been detected in 2 of Endeavor's engines, and all 3 engines would have to be replaced. Prior to the FRF on April 6th, each of Endeavor's engines had been static fired 3 times. Each rocket had endured more than 14 minutes of burn time. Yet when the engines were fired for the FRF, irregularities were found in engines 1 and 2. A high-pressure reading was recorded on one of the engines as it was being shut down following the FRF, and higher than normal vibrations were detected in a turbo pump on the other engine. Rather than replacing the faulty components, NASA said it would take less time to replace all 3 engines. The replacement engines came from the VAB, where they were being prepared to be installed on the Space Shuttle Atlantis for a flight this summer. Although NASA said the engine problems posed no safety concerns, the space agency decided to take advantage of the available hardware. During the launch of a shuttle, flight engineers rely on a series of sensors in and around the main propulsion systems for data. For the FRF, more than 50 additional sensors were mounted on the orbiter and the mobile launcher platform. Temperatures, pressures, and leakage in the aft compartment were all monitored using these devices. Before Endeavor can be cleared for takeoff, all of this extra equipment will have to be removed from the pad. In addition, visual inspections will be made of the orbiter's tiles and the SRBs and external tank. About 10 minutes after the FRF, the liquid hydrogen and liquid oxygen that remained in the external tank was slowly siphoned out and stored for reuse. With the new engines now installed on Endeavor, NASA says its newest orbiter is ready to fly. If all goes as planned, the next time the engines come to life, flight controllers won't have to hear the A word.
Plus 14, and we have an abort.
Pass is going 101, LVD 1 and BFS 0.
Like the solid rocket boosters, the Space Shuttle's main engines are reused, and it's not uncommon to switch engines on an orbiter in between flights. In all, 21 different engines have flown on the 46 shuttle flights to date. All of them have come from Rockwell International's Rocketdyne division in Canoga Park, California.
A total of 7 FRFs have been carried out by the launch processing team here at KSC. All but 2 were conducted from Launch Complex 39A, where Columbia, Challenger, Discovery, and Atlantis were tested for their maiden flights. A second test firing was required on Challenger after an elusive hydrogen leak was detected during the initial FRF. The other two firings took place at Launch Pad 39B. The first was performed on Discovery prior to STS-26 in 1988, the first post-Challenger flight. The test was required to verify improvements made to the hardware. The exercise was also helpful to launch controllers who had not taken part in an actual launch for more than 2 years. Endeavour's FRF at 39B marked the second time a shuttle's main engines were put to the test at KSC's northernmost launch site. NASA engineers weren't the only ones pleased with the outcome of Endeavour's FRF. The astronauts who will be riding on top of those engines in May were also on hand to keep a watchful eye on their spaceship. The 6-man, 1-woman crew of STS-49 has grown attached to Endeavour. So much so, the astronauts couldn't take their crew portrait without it. But who can blame them? The most advanced space shuttle ever built has been dubbed the jewel of NASA's orbiter fleet. The astronauts were on hand in California when Endeavour rolled off the assembly line last spring. Since then, the crew has made regular visits to KSC, where the orbiter is being prepared for flight.
They were here for FRF. They came by and walked around. We took them to a whole bunch of different places. The OPF and the vertical assembly building out at the pad, all over to try to get them to meet as many of the people who've worked directly on Endeavour as possible. They got to shake a lot of hands, and you're right, the workforce out here is always excited to see the flight crew, especially for the maiden voyage of a new orbiter like this.
Well, with the FRF now completed, NASA is in the final prep stage before launch. Endeavour's liftoff is tentatively scheduled for May 7th, and technicians are putting the final touches on the orbiter. Richard Horman is standing by with that report. Richard?
Thanks, Anita. The rotating service structure has been placed back in front of the orbiter to protect it from the elements. The RSS also allows technicians easier access to various parts of the shuttle. Now you can see the tip of the external tank and the solid rocket boosters just above the top of the service structure. The RSS will remain in this position until it comes time to load the cargo into Endeavour's payload bay. That cargo was expected to arrive here at the pad around April 15th. This move will be one of the last major milestones before Endeavour is cleared for takeoff. Just a few hours after the FRF, reporters were given a close-up view of the cargo that will be carried into orbit aboard the Space Shuttle Endeavour. The star of the show, of course, was the perigee kick motor that will be attached to the Intelsat satellite, which is stranded in low Earth orbit. In what is bound to be one of the most daring spacewalks to date, astronaut Pierre Thuot will attach himself to the end of the shuttle's robot arm and go after the wayward satellite. He will be armed with a specially designed capture bar, which he plans to attach to the satellite's aft separation ring. Using a steering wheel located in the center of the capture bar, Thuot will stop the spacecraft from rotating. With the aid of Bruce Melnick at the controls of the remote manipulator arm, Thuot will bring Intelsat 6 into Endeavour's cargo bay, where Rick Heeb will be waiting to help connect the booster rocket. It's a scenario that has been rehearsed time and time again in the shuttle training facilities at the Johnson Space Center in Houston. If all goes as planned, the capture, repair, and release of the satellite will all be in a day's work. But the operation will not come cheap to Intelsat. The International Telecommunications Satellite Organization is paying NASA $93 million for the undertaking. And Hughes, the company that built the perigee kick motor, is getting an additional $46 million. And what if the rescue mission doesn't succeed?
We have already made the payments, all the payments, so there's no refund coming to us if the mission doesn't succeed.
Also occupying Endeavour's cargo bay will be the assembly of station by extravehicular methods payload, otherwise known as ASEM. This hardware is mounted on a multi-purpose experiment structure and will be accessed by spacewalking astronauts Kathy Thornton and Thomas Akers. The mission specialist will demonstrate space station assembly and maintenance methods with the ASEM payload. With the flight readiness firing now completed, Endeavour's cargo is ready to be transported from the vertical processing facility to Launch Pad 39B. The last time a shuttle was launched from Pad B was back on June 5th, 1991, when Columbia began STS-40. Since that time, the pad has been off limits to give engineers time to upgrade some of its systems. Anita?
Thanks, Richard. Endeavour's maiden voyage will mark the 47th flight of the Space Shuttle program. As we mentioned earlier, the launch of STS-49 is targeted for May 7th. No official launch time has been set, but the orbiter is expected to launch at night.
Well, it's official. Daniel Golden is the new NASA administrator. The 51-year-old space executive breezed through a 2-hour-long Senate confirmation hearing on March 27th. Golden was in place as head of NASA on April 1st, one day after Richard Truly was relieved of his duties. The former TRW manager said the space agency's priorities should include completion of the $30 billion space station. As for a manned mission to Mars, Golden said such a feat is decades away.
I believe that what we have to do is first understand those critical technologies we have to develop. Second, I think we have to identify those precursor robotic missions that we want to perform to collect a database, and to list all those things we have to do to retire risk before we start talking about spending hundreds of billions of dollars. And we'll do it in a logical, sequential fashion and understand where we're going and show results as we're getting there. But to start sending human beings to those planets is going to take a significant amount of resources, and before we go spend very large quantities of resources, we have to know where we stand relative to the cost risk, schedule risk, and human risk, and I think it's going to take time to get there. And I certainly think...
Golden made his remarks during a press conference at the Kennedy Space Center shortly after the touchdown of the Space Shuttle Atlantis. Golden greeted the crew of STS-45 as they left the orbiter.
We felt it was very important to have the NASA administrator in place while the Shuttle Atlantis was up in orbit, and not have a situation develop where there wasn't an administrator in place. I was really thrilled. I came down here, and I want to tell you, when that Atlantis touchdown on the runway, I got teary-eyed. It was just an emotional experience. I've gone to launches of a whole bunch of shuttles, yet I've never seen them come back. They've taken my payloads out, sent them into space. I went back to activate the payloads, but I never took the time to see it land, and God, it was great. Went over, shook the hands of all the astronauts, and I told them that maybe now is the right time to challenge them to some physical competition, because they might not have been able to beat me. But Kathy Sullivan told me anytime you want it. First, let me say the shuttle is going to be our primary instrument for human access to space for the next decade or two. It's not realistic to believe that even if we were to go crash it, we would have a program in less than a decade that we could rely on for human access to space. I do believe we ought to take a look at new technologies and new techniques, and there is the NLS system currently under consideration. I haven't had time to review it. Given that the shuttle is going to be with us, we can't walk away from it. We can't use the shuttle as a source of funds to do all the other things we want to do. I think it's very, very important for NASA to be credible with the American public, to deliver on what it said it was going to do, and there are a bunch of wonderful people, Bill Lenore included, that are committed to making it safe. So I think we're going to take another look and see, have we starved the critical money for upgrading the shuttle? Have we starved some of the things we want to do to do everything we can to improve the safety and reliability of the shuttle? And we're going to be looking into that, and if we have to go spend money, by God, we're going to do it, because those wonderful astronauts ought to have the sense when they walk up to that shuttle, we are confident it's going to go. Now, I'm not saying there's anything wrong with it, but I really think that we have to look at that investment account.
Golden has lived in Southern California for the past 25 years. He and his wife, Judy, have 2 children. You know, Anita, it's kind of interesting that when the Shuttle Atlantis took off on March the 24th, Richard Truly was here at Kennedy Space Center for that liftoff. In his case, it was his goodbye liftoff, if you will, kind of a farewell launch. When the shuttle came back down on April the 2nd, the astronauts were greeted by a brand new NASA administrator, Dan Golden. It was kind of a changing of the guard, I guess you could call it, mid-mission.
That's right, Tom. It's been a pretty emotional time here at NASA for the administrators. This was Daniel Golden's first shuttle landing, and he said when the shuttle touched the ground, he shed a few tears. I imagine Dick Truly shed a few tears as well.
Well, yeah, that's understandable to a certain degree. The launches and landings are certainly magnificent sights, and some of us are touched by emotion. In this particular case, these two administrators probably had very different reasons, however, for crying.
Well, talking about Richard Truly, the former NASA administrator spent his last day on the job bidding farewell to his employees. The former astronaut, who worked his way to the top of NASA hierarchy after joining the space agency in the 1960s, appeared on NASA television one last time.
Across NASA, buildings are going up for Space Station Freedom. And the Magellan team just won, it was just announced that the Magellan team has won the Goddard Trophy this year and is going to be honored here in a few days here in Washington. But times are tough, and to keep up these successes, as Dan Golden is sworn in, perhaps even tomorrow, but certainly in the next few days as the NASA administrator, you're going to need his support, and I know you're going to get it. But he's also going to need your support, and I urge you to give it to him 100%, and I know that you will. This year we had to say goodbye to two great NASA leaders, Jim Fletcher, and also, most recently, to Jim Webb. But I can tell you, you're not going to have to say goodbye to Cody and me, because we're going to be in the stands cheering you on as you go forward. So all I can say is keep up the great work, and I have loved every minute of it. So best of luck to you. Thanks a lot.
Truly kept a stiff upper lip during his farewell address, but sources close to him have said the former head of NASA felt he had the carpet pulled out from under him. Many people in the space community have criticized the way the White House handled Truly's departure. According to one critic, Truly knew the White House wanted him out, but he never thought they would fire him.
William Lenore, NASA's Associate Administrator for Spaceflight, submitted his letter of resignation on March 30th. The departure of Lenore and Richard Truly leaves the space agency without two of its strongest supporters of the space shuttle. Lenore flew as a mission specialist on STS-5, the first operational mission of the space shuttle. The Miami native originally joined NASA in 1967. He served as a backup astronaut for the Skylab 3 and 4 missions. Lenore left the space agency in 1984 to pursue private interests, but rejoined NASA 5 years later. During Lenore's tenure as Associate Administrator, NASA completed a major restructuring of Space Station Freedom, reducing its costs by $6 billion.
Former NASA Administrator James Webb, who helped pave the way for the Apollo missions to the moon, died March 27th at Georgetown University Hospital in Washington. He was 85 years old. Webb was appointed to the post by President John F. Kennedy in 1961. His responsibility was to answer Kennedy's call to put a man on the moon by the end of the decade. Under Webb's leadership, the space agency developed the techniques and machines that would later be used to transport humans to the lunar surface.
Space Highlights, 1965, an eventful year in space. These pictures, telecast live from the moon, were recorded by the Ranger 9 spacecraft just before it slammed into the lunar surface. This was the final
As the Apollo program took shape, so did NASA's reputation. Webb is credited for bringing together the various players from the political arena to support the Apollo program. Webb was no stranger to Washington. He had served as director of the Bureau of the Budget and Undersecretary of State. Although he left NASA before the first moonwalk in 1969, Webb will be remembered for spearheading NASA's glory days, a time when dreams were just becoming a reality. Anticipating a reduction in space funding, Webb resigned from NASA in 1968. Well, during one of his last public appearances as NASA administrator, Richard Truly called for the resumption of the Teacher in Space program. Truly urged Dan Golden to place school teacher Barbara Morgan on an upcoming shuttle flight. Morgan was the backup teacher for Krista McAuliffe, who was killed aboard the Space Shuttle Challenger in 1986. McAuliffe and Morgan were among the 10 finalists selected in the Teacher in Space program in 1985. NASA received 11,000 applications after President Ronald Reagan announced a school teacher would be the first private citizen in space. The finalists were sent to the Johnson Space Center in Houston, where they underwent physical exams to see if they were fit for spaceflight. The selections were later announced by then Vice President George Bush.
It's not often that a teacher is at a loss for words. I know my students wouldn't think so. I've made 9 wonderful friends over the last 2 weeks. And when that shuttle goes, they might be one body. But there's going to be 10 souls that I'm taking with me. Thank you.
That's great.
The plan called for McCullough to conduct 2 lessons from space, which would be broadcast via satellite to schools across the country. As a backup crew member, Barbara Morgan trained for the flight along with McCullough. But after the Challenger accident, the Teacher in Space program was put on an indefinite hold, and Morgan was never assigned to a new flight. During a speech to the National Congress on Aviation and Space Education, Richard Truly said Morgan is ready to fly into space, and he asked Dan Golden to put the elementary school teacher on an upcoming flight. Truly said the time has come to begin a formal program of teaching from space. It was a vision he shared with Krista McCullough.
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
Atmospheric scientists were treated to an extra day of experiments thanks to the crew of STS-45. An international team of scientists hailed the work of the Atlantis astronauts who carried out the flight of Atlas I. Designed by the astronauts, the STS-45 crew insignia depicts the shuttle launching from the Kennedy Space Center into a high-inclination orbit. From this vantage point, the Atmospheric Laboratory for Applications in Science, or ATLAS payload, can view the interactions between the Earth and the Sun. The colors of the setting sun, measured by sensitive instruments, provide detailed information about ozone, carbon dioxide, and other gases which determine Earth's climate and environment. Encircling the scene are the names of the STS-45 crew members: Commander Charles F. Bolden, Jr., Pilot Brian Duffy, Mission Specialists Michael Foale, David Leestma, and Catherine D. Sullivan, and Payload Specialists Dirk Freemount and Byron K. Lichtenberg. The additional star in the ring, located above the A in Atlas, is in honor of Charles Chappell and Michael Lampton, who served as alternate payload specialists for the flight. During the 9-day mission, the astronauts used the 12 instruments in the Atlas payload to study the chemistry, physics, and movement of the middle and upper atmosphere. One of the instruments used early on in the flight was the Space Experiments with Particle Accelerators, otherwise known as CPAC. Using the black spheres you see mounted in the cargo bay, the crew was able to generate artificial aurorae by firing electron beams into the Earth's magnetosphere. Diagnostic equipment searched for electric fields that were parallel to the magnetic field in the auroral zone. Now, data gathered from CPAC is important to scientists who are trying to learn why aurorae disrupt telecommunications, power transmissions, and spacecraft electronics. STS-45 was scheduled to get underway on March 23rd. However, the launch was delayed 24 hours after liquid hydrogen and liquid oxygen leaks were detected in the orbiter's engine compartment. NASA was able to quickly remedy the problem, which was the result of a faulty seal between the external tank and the orbiter.
Including the fixed service structure and the umbilicals. The team is, of course, visible with their day-glow orange protective coveralls. These are anti-static and flame-resistant. And each member also carries a self-contained emergency breathing unit with about 10 minutes of air. An inspection of the pad and the mobile launcher platform and the space shuttle itself was also made yesterday. This included a thorough inspection of the tank prior to loading the cryogenic hydrogen and oxygen into the tank late last night. This is shuttle launch control at T-minus 2 hours, 55 minutes, 10 seconds and counting. The astronauts now coming down the hall, boarding the elevator to go down to board the Astrovan for their short ride out to Launch Pad 39A. Crew should begin boarding about 5:15, in about a half hour from now. Led by Commander Charlie Bolden, Ethan Sullivan, Dirk Fremont, Byron Lichtenberg, Michael Foale, Brian Duffy. And Dave Leesman.
Atlantis was finally launched on the morning of March the 24th. We pick up the countdown now at just under the T-minus 4-minute mark.
Final check now of the orbiter's flight control elements. Standing by for gimbaling the 3 main engines. Rudder elevons and speed brakes all have moved through a program test pattern, and they are verified ready to go. T-minus 3 minutes, standing by to gimbal the main engines. The main engines are now in the start position.
Let's go for ET LO2 pressurization.
Starting now to pressurize the liquid oxygen tank on the external tank. Atlantis now on internal power. Atlantis being powered by its onboard fuel cells.
TLPOTC.
Retraction of the gaseous oxygen vent hood now underway.
No unexpected errors.
Cedra, that's in work.
Pilot Brian Duffy reports that the action to clear the caution and warning memory system is now in work. He'll be reporting back.
The caution and warning's clear and no new messages.
That action reporting complete. No surprises there.
Close and lock your visors. And
yeah, ahead, OTC.
Flow. Good luck and Godspeed, Atlantis.
All right, thank you guys very much. We're
let's go for ETLH2 pressurization.
Replenishment of liquid oxygen to the external tank is now being terminated.
1 minute 30 seconds.
At T-minus 31 seconds, we'll have the handoff from the ground launch sequencer to Atlantis' onboard computers. The Space Shuttle has now been disconnected from all ground propellant loading systems. T-minus 1 minute and counting. Ground launch sequencer verifying that the main engines are ready for ignition. The heaters around the joints of the solid rocket boosters are being turned off. Residual hydrogen burn igniters have now been armed. They'll be fired at T-minus 10 seconds to burn off any residual hydrogen under the main engine nozzles. Sound suppression water system is being armed. T-minus 35, standing by for the handoff. T-minus 31, the handoff is complete. Onboard Atlantis computers now controlling. Booster hydraulic units have been started and a final steering check of the engine nozzles is underway. T-minus 20. Body flap and speed brake in the launch condition. Sound suppression water system activated. T-minus 10, 9, 8. We're go for main engine start. 6, 5. Main engine start. 3, 2, 1. And liftoff of the Space Shuttle Atlantis on a mission to planet Earth.
Houston, Atlantis in the roll.
Roger, roll, Atlantis.
Houston now controlling. Atlantis is rolling to the proper upsound down position for its climb to a 57-degree inclination, 160 nautical mile high orbit. Three engines now throttling down as Atlantis prepares to pass through the air of maximum aerodynamic pressure. Atlantis speed now 500 miles an hour, downrange 1 nautical mile, altitude 13,600 feet. One minute since liftoff, altitude now 33,000 feet, downrange 3 nautical miles, Atlantis now traveling 1,023 miles an hour.
Atlantis, Houston, go at throttle up.
Roger, John, go ahead, throttle up.
Three engines now throttled back up to 104% of rated capacity and operating well. Good hydraulic systems, good electrical systems. Altitude 68,000 feet, downrange 8 nautical miles. Atlantis now traveling 1,705 miles an hour. One minute 50 seconds since liftoff. Atlantis now traveling 2,386 miles an hour. Flight controllers standing by for burnout and separation of the solid rocket motors.
Atlantis, 2 engines, Zaragoza.
Copy, John, 2 engines, Zaragoza, good SRB SEP, good stable Team Ecos.
And Atlantis, we copy, performance nominal.
Copy, nominal performance.
Those calls indicate that Atlantis' first stage performance with the solid rockets was as planned, and Atlantis could now perform a landing at Zaragoza, Spain on only 2 engines if that were to become necessary. However, 3 engines still operating well at 104%. Altitude 225,000 feet, downrange 54 nautical miles, Atlantis traveling 3,400 miles an hour. Time since liftoff, 3 minutes.
About 9 minutes after launch, the shuttle's large brown fuel tank is jettisoned from the orbiter. By this time, the shuttle has entered space, and the separation of the external tank cannot be captured by cameras on the ground. But a camera aboard Atlantis during STS-45 was able to snap this rare photo of the external tank shortly after separation. The burn scars you see near the top of the tank are normal and are the result of separation motors used to push the SRBs away from the tank. The charred bottom is caused by similar motors and by the SRB exhaust itself. With Atlantis now in orbit, it was time to put Atlas I to work. We present to you now the flight of STS-45, narrated by the Atlantis astronauts during their post-flight press briefing.
This is a scene of payload bay door opening, which is about an hour and a half into the flight. It was already pretty clear, I think, to all of us that Atlantis had a high probability of just being a superb platform for our work for 9 days, because this had gone far more gracefully than you ever see it in any of your training, and really gives you a comfortable feel for starting a busy flight plan. We turned to right away and had the lab powered up in short order, and you see the typical view that we looked at out the payload bay windows here, with the black balls on their platforms, which are the charge collecting devices that CPAC used to provide a return path for electrical current.
This is where the orbiter crew did most of the work up on the forward deck. We're getting right here. We're finishing up our flight control system checkout before re-entry.
And over 220 maneuvers to accomplish over 9 days to make sure all the experiments were pointed in the right directions.
The space lab operation of the payloads were done from the aft flight deck and mostly in the dark. That's why we don't have a lot of pictures of it, because it was during the nighttime. Like here, this API came alive, like I was saying. It was getting out of the locks and pointing then to an aurora, or to the try to find artificial aurora. So it was always exciting to see these experiments actively working. It is pointing up.
Okay, this is the scene of the aurora. The Earth's up, as you see it on the screen there, and you can see the three little turrets of the API camera. I want you to, as you zoom in here, look to the middle left, and you'll see a meteorite go by, actually above us in the picture here, but it's below us as far as the Earth goes. The aurora, of course, are generated by, it's coming up now. There you go, yeah, you saw it. The aurora generated by protons coming from the sun, spiraling down the field lines.
Here's the electron beam coming out just a little right of center, and superimposed on that is the results from the API camera. You can see a little glow to the left of center about every 15 seconds. We're going to cut back and forth. Here's another beam firing.
And then you see the glow that you see in the middle is the natural aurora, and in the middle of that you can see the spot from the beam, and that was really the first time that this has been done in space, and that we have been able to watch it with a camera. So
that beam really did look like one of the phasers that is in Star Wars or Star Trek. It's really an amazing phenomenon to see this come out of the orbiter for the first time.
In addition to the electronic detector that the API experiment involved, the investigator also had supplied us with a fairly complex set of photographic cameras and optical equipment. And you see me here on one of those tests. Often the target was the same as what the detector was looking at, but we could use different filters or other optical elements to get complementary data. Again, this one was photographed to show you what we were doing when the lights were up a little bit. Normally this was done by feel and by memory of the procedure in the dark as the target went sliding by.
Everybody has something that they call their favorite when you go fly, and mine is lightning, because I always tell everybody that to me it's like an orchestra playing, and it seems like the lightning plays off each strike. You know, you'll see one and it just ripples all across the face of the Earth. It's a beautiful spectacle. You can actually see the Earth limb in the upper left-hand corner there, and the big city, or the bright spot you see that's steady there, is the city of Buenos Aires. As we're coming up on an ascending orbit here, and we're actually going up along out over the Atlantic Ocean off the east coast of South America.
This is the sunrise, the picture that you have with the different colors, so that from red to blue, sometimes it's really, you see nearly all the colors and the different layers. There are quite a number of layers. That some of these colors are produced by the dust that is in the atmosphere. So it's since the eruption of the Pinatubo, we have quite some dust, and this adds to the red glow that we see in space.
This is the redshift going to work in the morning. As we put new meaning into tumbling out to go to work in the morning, tumbling out of bed. But that's the bunks that we used, and they work very well to give us a good night's sleep while the other shift was up working. Of course, we have to have our actors on board, and it's...
It was tiresome work sleeping all night in those bunks.
Brian had mentioned earlier that we were going to show you some of the mundane types of things that go on, and so for the next few seconds here you'll get to see us as we prepare food. We did a number of things that you would not necessarily think are done on a spaceship, but you've got to eat, and that means that somebody's got to go to the kitchen. That's our water dispenser and an oven that every once in a while you'll see Kathy open the door here and stick food in. The foods were very, very tasty. Very, very filling, although you wondered that because we seem to be eating all the time. We really enjoyed the food and drink, and so that's kind of one of the things that's going on here. In addition to this, something you won't see, we had to clean filters. You had to dust and mop, and we'll show you a little picture of us swabbing, as I call it, later on. Here Dave's eating one of the favorites of almost all the crews, and that's shrimp cocktail. So you get a chance to see some of the better food there. And it behaves much better than it does down here. Gives you an opportunity to think about it. Here we were doing some of, another one of the more fun things to do is decide how you would like to have your M&Ms. You just turn them free and then you go get them. And kids always have a very good time with this. They can imagine being there, and I'll do a reverse slam dunk here in a second and gobble up one.
One of the secondary experiments we had on board was the SAR-X, or the Shuttle Amateur Radio Experiment. Here you see Dave talking to someone. I don't remember. Do you remember where you were, Dave, doing that?
I think I was talking to a school, and you'll see the concentration trying to listen to the kids' questions here in a minute and then be able to make answers. It was kind of fun to talk to auditoriums full of school kids while you're flying right over the top of them.
3 of our crew members, Dave, Kathy, and Brian, talked to all 7 continents during our 9 days in space.
Well, here you see our commander keeping fit for the entry, and I'm really glad he did that, because he did an excellent job. Charlie was doing a DSO for 30 minutes every day running, which he sometimes enjoyed, but maybe not. So this is a view of what Charlie does when he's commanding.
You see what the crew is doing.
Yeah, meanwhile, down below, Charlie said something about, why don't you, Brian, you take your shift downstairs and swab the decks. And I didn't know what that meant, because I'm not in the Navy. So he had to explain it.
But we found out on Blue Shift very quickly what that meant, as we moistened up washcloths and went all over every surface we could find to, as Charlie said before, neaten the ship up and return it in proper form to the folks that had given us such a good spacecraft.
Yeah, and even I was employed for that, and it's something they have never told them before, that they have to do that on board. And I never got any training for it either.
Well, finally, after 9 days, it was time to come home, and I must say I really wasn't ready to do so, and I don't think anyone else was. We were very, very comfortable on orbit. We had a very successful mission. We had a good routine, and we were enjoying ourselves immensely. And this is really the beginning of the end of our glorious flight.
This is the plasma going out the back end of the orbiter, and it was really pretty impressive as Kathy and I took some pictures back out the overhead. And then we took them back out forward, and you can see the reflections of that on both Brian and Charlie as we're going through entry. It is totally dark outside, by the way.
The camcorder can't really do this justice. In particular, the colors, which are all sorts of shades of salmon and pink and orange, they really do look somewhat like the inside of a blast furnace.
Central Florida residents received an early morning wake-up call as a pair of sonic booms signaled Atlantis' return.
Your energy looks good. Attack acquisition, Atlantis.
Okay, we copy, Sid.
After nearly 9 full days in orbit, Atlantis was coming home. The orbiter's retro rockets were fired at 5:20 a.m. Eastern Time on April 2nd. NASA's long-range tracking cameras provided this spectacular video of the orbiter as it made its majestic approach to the Kennedy Space Center.
23 nautical miles. Atlantis descending now at 403 feet per second.
Atlantis, Houston, slightly low at the 180.
Okay, we copy. Slightly low at the 180, Sid.
Atlantis, Houston, we show you low at the 90, but converging to glide slope.
Okay, we copy, Sid. And Houston, Atlantis, we have the runway in sight, onboard nav and guidance look good.
Altitude 2,000 feet, pre-flare maneuver underway. Take some of the steepness out of the angle of approach. Wheels coming down. Final flare. Main gear touchdown. Holden derotating the nose. Nose gear touchdown. Atlantis returns to the spaceport. Rolling out on runway 33.
For those of you keeping track, the main gear touchdown occurred at just past 6:23:05 a.m. and wheel stop took place at 6:24:04. Total mission elapsed time for STS-45 is 8 days, 22 hours, and 9 minutes.
Welcome back to the planet, Atlantis. Congratulations on an outstanding flight. This first in a series of missions to study Earth's environment from space has set the standard for those to follow.
Components for the Space Shuttle system come from all over the United States, but they all come together before a launch in one spot here at Kennedy Space Center. That's the Vehicle Assembly Building. Well, we got a VIP tour, and you're coming along. For miles around Kennedy Space Center, you can see this. It is the Vehicle Assembly Building, or VAB. It's here that the orbiter is mated to its launch stack. That's the 2 SRBs and the external fuel tank. Let's go on inside and take a look around. The name says it all. The Vehicle Assembly Building is where the Space Shuttle components come together. One by one, the SRB segments, the external tank, and finally the orbiter are brought into the VAB for final assembly. But the VAB isn't your average building. When you're dealing with booster rockets that are 149 feet long and fuel tanks that are 28 feet in diameter, you need a facility that's going to offer you something more than a little bit of elbow room.
To walk into the building, you automatically look up toward the roof because there's nothing but no beams or anything within the transfer aisle where we do all of our major lifting from. There's nothing between you, the floor, and the roof, so it's just a breathtaking sight. Well, the building itself is 525 feet tall. It was built that high for the Saturn V rocket when they were assembling it. It covers a ground area of 8 acres, so I think it's the 3rd largest in volume in the world.
The Vehicle Assembly Building is one large building, 130 million cubic feet. That makes it one of the world's largest buildings in the internal volume category. Now, the building is 52 stories high, which can make for some unusual atmospheric conditions in the building. It's all open inside, and with a building that tall, occasionally you get condensation on the metal, and that leads to one thing. We call it showers.
There is a possibility that we could get a shower, actually a cloud, come into the building because it's so tall. There are days when the roof is just soft in, you can't see from the outside the roof, and the fog comes in. And if the doors are open and you're looking inside, you can actually see some of the fog kind of rolling in to the building.
This is what the VAB looked like when construction workers first started putting up the steel framework in the early 1960s. Back then, the building was erected to accommodate the mammoth rockets that would send the astronauts to the moon. Remnants of the Apollo program can still be found in the VAB today. But for the last 14 years, the assembly building has been used as a nesting place for the huge shuttle stacks that go rolling out the doors to the launch pad. Engineers are in the process of stacking the SRBs for the June flight of Columbia. Now, when things go as planned, that takes about 4 weeks. As you can tell, they're just about done with the job.
A booster is built up of 6 parts. By the time we get parts, there are usually 5. You've got 4 segments that have solid propellant in them, and then you've got an aft skirt, and that has APUs or HPUs. It's hydraulic power units. When we start stacking them, we have to level the first booster or the first segment. We have to level it, and we use shims to level that, and we run optics to make sure that we're stacking them correctly.
The other side of the Vehicle Assembly Building is used to store some very important hardware. If you look over here, look closely and you'll see 3 orange-colored objects. Those are actually 3 external tanks laying on their sides in storage for future missions.
That comes in from Louisiana on a barge. It comes around the tip of Florida and up through some the International Coastal Way and up into this barge canal here. We'll offload it from the barge and take it into the building, and we'll hook 2 cranes up, and we'll actually lift it up and rotate it to the vertical, and from there we'll take it and put it into a checkout cell where we do receiving inspections on it. We do leak checks to verify that it's not going to be leaking, and also we'll install some kits like range safety devices on it, and just prepare it to be mated up to those 2 solid rocket boosters.
Once the external tank is in place, the orbiter is brought into the VAB and hoisted up and over 16 floors to be mated to its fuel tank. Using a yellow harness such as this, workers are able to lift the 165,000-pound orbiter and set it on top of its steel platform. From there, it's out to the launch pad and beyond.
It's now time to check in on the status of the orbiters for this April 1992.
The Space Shuttle Columbia is getting ready to be rolled over to the VAB for mating to its external tank and SRBs. This in preparation for STS-50, the flight of the United States Microgravity Laboratory. Work items completed in April include installation of the main landing gear and nose gear. Columbia's new drag chute has also been installed. Columbia is scheduled to launch in June. The dismantling of Discovery continues in Bay 2 of the OPF as technicians remove and inspect the orbiter's major components. Discovery's power reactant and storage distribution tank has been disconnected, as has the main propulsion system helium tank. Its next flight is STS-53. That's a DoD mission planned for December. The Space Shuttle Atlantis is in OPF Bay 1, where NASA workers have removed its main engines. A different set of rocket motors will be installed before the orbiter's next mission this summer. The next flight for Atlantis is STS-46. The tethered satellite system will be the primary payload aboard Atlantis, which is scheduled to blast off from Pad 39B the second week in July. It will be a mid-morning launch. Atlantis is scheduled to land at the Kennedy Space Center. And the much-anticipated, highly ambitious maiden voyage of the Space Shuttle Endeavour draws near. The orbiter is sitting at Complex 39B, waiting to make space history with the Intelsat Rendezvous mission.
Digging into the Shuttle Vision mailbag now, we have a letter this month from a viewer in Sokol, California. Martin Mogard writes, "Dear Shuttle Vision, with the shakeup at the top of NASA, you will be covering the latest on that subject. Maybe you could explain in more detail where exactly Dan Quayle fits in, and what does he know about space science? Is he simply another politician messing things up, or is he legit?" Well, as you may know, Dan Quayle is the head of the National Space Council. Although his educational background is in law, not space science, this position does enable the Vice President to set certain standards regarding space policy and the direction of the space program. His most recent initiative was a space policy directive that will divide NASA's responsibility for the future U.S. Moon-Mars program. It's no secret that the National Space Council has been at odds with NASA's astronaut-oriented management. The result of this conflict was the ousting of Richard Truly. There are many rumors that the Vice President is interested in putting weapons in space, specifically the Strategic Defense Initiative program. Many fear that he will use Daniel Golden as a tool to carry out his own initiatives. But as Golden said in his own news conference, ultimately, it is he who will be in charge of NASA. Thanks for your letter, Mr. Mogard. Now, if you have a question you'd like to have answered on Shuttle Vision, write to us at P.O. Box 92012, City of Industry, California, 91715-2012.
Okay, that closes this edition of Shuttle Vision from the Kennedy Space Center. We'll be back here next month for an in-depth preview of Endeavour's maiden flight. We'll also introduce you to Endeavour's crew, and we'll take you behind the scenes here at KSC for a look inside the orbiter processing facilities. Until next month, I'm Tom Marshall.
And I'm Anita Vogel. We'll see you next month.
Bye-bye.
Hotel accommodations provided by the Cocoa Beach Hilton. When visiting the Kennedy Space Center, stay at one of Florida's most popular beachfront hotels. For reservations, call 1-800-526-2609.